Okay, our last section for this week is section 4.3. This will be the last section you're responsible for both quiz 4 and also for exam 1. We're going to talk about right triangle trigonometry. So kind of we really have already talked about all this, but we just want to make sure that we understand it in the context of what we're going to be using this for. So here's our learning objectives, and these are some of the examples we're going to go over here. I don't want you to worry about this concept of a co-function. So just ignore this example. I won't have you do anything in your homework like that example. So this use equal co-functions of complements, don't worry about. I'm not going to be talking about that. All right. So right triangle notation. Right triangle notation just means we're going to be working with problems where we want to construct right triangles. Okay, so I'm always going to label the sides this way. So this 90-degree angle is often called angle C. Sometimes it's not labeled. I don't care if you don't label. It's 90 degrees. Why label it C? Then I'll label two angles, it doesn't matter which one, as A and B. That means I want you to think of as the side opposite the angle A will label as little a, and the side opposite the angle B will label as little b. And so the side opposite the 90-degree angle, which technically I guess would be capital C, will label as little c. The reason we do that is like the a squared plus b squared equals c squared from Pythagorean theorem, so I'm going to label the angles this way too. Okay, so in the second example, it says, given right triangle ABC, where C is the right angle, A is 38, and capital A is 51 degrees, find B to the nearest integer, little b. So if you go to your picture, understanding that that right triangle notation is the general notation, what do we know? Well, we have angle A is 51 degrees. We have the side opposite angle A is little a, which is 38. And we want to find little b. So there's different ways we could do it. We could figure out what angle B is because all the angles of a triangle have to sum to 180. So 90 plus 51 plus this guy's got to be 180. Or I just use the information I have and I say, well, what do I know? I know this. I know that opposite over adjacent of an angle would be the tangent of that angle. So I know that the tangent of 51 degrees is the opposite, which is 38, over adjacent, which is b. And I could simply solve this for b, right? Multiply both sides by b and divide both sides by tangent of 51 degrees. So b equals 38 divided by the tangent of 51 degrees. It comes out to be 30.77. Make sure you plug all that in your calculator and you get that right answer. Your calculator's got to be in the correct mode, right? If we're using degrees, it's got to be in the degree mode. If you're using radians, it's got to be in the radian mode. Okay, example 3. Oh, I didn't write the problem. Example 3 says, if f of theta is 2 sine theta minus the sine of 2 theta, find f of pi over 6. Express the answer as a single fraction. Okay, so f of theta is 2 sine of theta minus the sine of 2 theta. So we want f of pi over 6. So you just plug in pi over 6 for theta. So 2 times the sine of pi over 6 minus the sine of 2 times pi over 6, which is pi over 3. So the sine of pi over 6 is the sine of 30 degrees. So I have a 30, 60, 90 right triangle. Side opposite 30 is 1. Side opposite 60 is root 3. And the hypotenuse is 2. So the sine of pi over 6 is opposite over hypotenuse, which is 1/2. 2 times 1/2 is 1. Pi over 3 is 60 degrees. So now I have a 60, 30, 90. So the side opposite 60 is root 3. Side opposite 30 is 1. And I want the sine of that, sine of 60 degrees, or the sine of pi over 3 is root 3 opposite over hypotenuse, root 3 over 2. So I have 1 minus root 3 over 2. Often we want to put this into a single fraction like it asked us to do in the example. So just 1 is the same as 2 over 2, so I get 2 minus root 3 divided by 2. And as a fourth example in this section, right triangle trigonometry, we got a word problem. So some of your problems will be word problems. It says we have a 50-foot tall tree which casts a 40-foot shadow. Find the angle of elevation of the sun to the nearest tenth of a degree. So I'm going to put this side as my 50-foot tall tree. I'm going to put this side as my shadow, so the sun's over here. So this is 50 and this is 40. And so what's the angle of elevation of the sun? That means to an eyeball observer, I want to know what's the angle straight up to the sun. So what is this angle here? Well, what do I use if I know opposite and I know adjacent? I use tangent. Tangent of theta is opposite over adjacent, which is 50 over 40 or 5/4. So if I want to find that angle now using my calculator, that's not one I should know. Okay, I don't know anything with 5/4. I have to use what's called the inverse tangent button. We haven't talked about inverse trig functions yet, but you need to know how to use this button on your calculator. So make sure you find it. It's usually second tangent, right? You find the tangent button and hit the second first. So second tangent to get tan inverse. And then you want to make sure whether you know you're in, this says find it to the nearest tenth of a degree, so we want to be in degree mode. Hit the inverse tangent. Again, that should be second tangent of 5/4, and you should get 51.3 degrees. Again, make sure you try that with your calculator so you know you're okay with doing all this.